Welcome to the Explainer. So, today we're going to dive deep into the hidden architecture that powers just about every single app you use, database design. We're talking about going from, well, the complete chaos of raw data to the clean, elegant structure of code. All right, let me ask you something. Have you ever stopped to think about your favorite social media app or that online store you love? How in the world does it handle a massive tidal wave of information from millions of people, all without just crashing and burning? You know, the secret sauce here isn't just about having gigantic servers or tons of storage. It is all about having a brilliant design from the very beginning. Without a solid plan, all that data just collapses into a jumbled, unusable mess, a total data meltdown. You see, when a design is bad, it leads to a couple of massive headaches. First, you get data redundancy. That's where you're literally just wasting space, storing the exact same piece of information over and over again. And then you get data anomalies, which are these nasty little errors that can corrupt your data when you try to update or delete things. It gets messy fast. Okay, so how do we fix this? How do we actually fight this chaos? Well, just like building a house, you need a blueprint. You need an architect's plan for your data before you even think about building anything. And there's actually a whole process for this. It's called the database life cycle. It's basically a roadmap that stops you from just jumping in and coding. You start by figuring out what you need, then you design it on paper, and only then do you start building and maintaining it. It's a journey from idea to a real working system. At the heart of this whole blueprint is this incredible idea from the 1970s called the relational model. And the genius of it? It's all about simplicity. It's about organizing all your information into basic two-dimensional tables that can, and this is the important part, talk to each other. And get this, it really just boils down to three simple building blocks. You've got your main container, the table. Inside that table, each row represents one single thing, like one student. And the columns, well, they just describe the details about that thing, like a first name, last name, and so on. That's it. Okay, so what does that actually look like in the real world? Let's take a look. Here's a super simple students table. See, each row is a unique person. There's Alice, then there's Bob. The columns tell us what we need to know. Simple, clean, organized, no chaos here. All right, so having one table is great and all, but you know, the real magic, the real power happens when you start connecting them. So how do we link our students to the specific courses they're taking? Well, the answer is these incredibly important things called keys. The first and most important key you absolutely have to know about is the primary key. Think of it like a unique serial number for every single row in a table. It's that one piece of information that guarantees we can find that exact record and no other. It's non-negotiable. So if we look back at our students table, that student ID column, that's our perfect primary key. And why is it perfect? Simple, because no two students can ever have the same ID number. It is a guaranteed unique identifier, and that's exactly what we need. Okay, so if the primary key is the unique address for a row in one table, think of the foreign key as, well, it's the thing in another table that knows that address. It's the connector. It's the bridge that lets our tables actually form relationships and talk to each other. This is the magic. Now check this out. In this enrollments table, see that student ID column? That is a foreign key. It's not there to identify the enrollment itself. Its whole job is to point back to a specific student in our students table. And just like that, boom, we've connected Alice, Student 101, to two different courses. But hold on, what good are all these links if they're, fragile? What if they can break or point to something that isn't even there anymore? We need rules to keep the data honest. This is where we introduce integrity constraints. Think of them like the official building codes for our database. This is a big one. Foreign keys enforce a super important rule called referential integrity. Basically, it stops you from creating what we call orphan records. You just can't have an enrollment for student ID 999 if a student 999 doesn't exist in the students table. The database itself will just say, nope, not going to happen. All right, so we've got the problem, we've got our blueprint, we've got the rules. Now it's finally time to actually build this thing. And to do that, we use a special language called SQL, specifically the part of it designed for defining our data structure. And this is the moment where that blueprint turns into actual working code. With a command like create table, we're literally spelling it out for the database. We're saying, hey, make me a table for students. It needs a student ID column, which has to be a number, and by the way, that's its primary key. And then for our enrollments table, you can see right there in the code how we make that official link. We declare the student ID column, and then we explicitly state that it's a foreign key that references our students table. That connection is now baked right into the very structure of our database. But, life happens, requirements change, no design is set in stone forever. What if, down the road, we realize we need to start collecting student email addresses? A really good design has to be flexible, right? Of course, and SQL has our back. There's this command alter table that lets us make changes without having to tear the whole thing down and start over. So here, we're just easily adding a new email column. And we can even add a unique rule to make sure no two students have the same email. Pretty cool, huh? When you really think about it, all of this work, the planning, the keys, the code, it all serves one primary purpose. It's about building a system you can actually trust. A system where the data is always accurate, always consistent, and easy to get to when you need it. All right, so let's do a quick recap of this whole journey. Number 1, always design first. A good plan saves you from a world of chaos. 2, the relational model is your best friend. Tables, rows, and columns. That's the core. 3, keys are, well, they're key. Primary and foreign keys connect everything. And 4, SQL is the powerful toolkit you use to bring it all to life. If you walk away with just one thing today, I hope it's this: the incredible power of a single, well-placed rule. Just one foreign key constraint can automatically enforce consistency and integrity across thousands, maybe even millions of records. It's just incredibly elegant and efficient. So there you have it. We've laid out the fundamental blueprint, and we've shown you the tools of the trade. The principles of good, solid design are now yours. So the only real question left is, what are you going to build with it?